Okay, so here's the first video for section 6.3, dimensional analysis. So the book defines dimensional analysis as the process of including units of measurement as factors when you compute. The easiest way to think of it, honestly, for most people is that you're converting units. So a lot of times you do this in physical science or biology class, so now we're looking at it in a math class. Hopefully you have some, at least minimal experience related to it ahead of time, but if not, here's the first introduction for you. So what's really going to be important for you when you're doing this section is having your references with you as far as your unit conversion. So either your textbook has them, or I guess you could look them up online, but you're going to have those units unless you got them memorized. So here's the book's first example, converting 70 miles per hour to miles per minute. Okay, so you'll notice there are two units because it's a rate, miles per hour. The next one is miles per minute. So luckily we can keep miles the same. Our real goal is going to be doing miles or changing hours to minutes. So it's a nice kind of straightforward, simple example to get you started. So you need to convert miles per hour to miles per minute. Now what we do, at least the book's way of doing it, is they use fractions. Some of you guys that have done this in physical science or biology probably remember doing this, creating these like T-charts, which is fine. I don't care how you do it. When I learned it in high school, I did the fractions, but when I did it in chemistry after freshman year, we did it with the T-charts. So the real key is, with dimensional analysis, you're canceling units. So I've got miles over hours because it's miles per hour, and now I'm going to multiply by something to cancel off the hours and leave just minutes. So I've got miles over hours, and now I'm going to do hours over minutes, canceling off the hours, giving us miles per minute. Our conversion then is 1 hour to 60 minutes, because that's what's equivalent for miles and hours, or hours and minutes, is that 1 hour is 60 minutes. So we start off 60 miles per hour, 760 miles per hour, excuse me, and then I'm going to go hours to minutes. So 760 miles per hour times 1 hour over 60 minutes, that's going to cancel off the hours, and then you get 760 over 60, and then in this section it's perfectly acceptable, even though you cancel out the zeros and then divide by 6, to just grab your calculator and multiply it out. But I've got to see this portion here of the problem. So this example, we traveled about 12.7 miles per minute. Okay. Now, first example for us. Okay. The average teenager spends $1,742 per year on fashion-related items. How much is this per week? And I don't know if this is true or not. It seems like a lot of money. But either way, we know we have $1,742 per 1 year. Okay. What I want to turn that into is dollars per week. So I'm keeping dollars the same on top. I'm just going to convert years to weeks. So the only unit of conversion I have to know is, how do I get from years to weeks? Well, there's a more technical conversion, but for us, what we're going to use is the fact that 1 year is 52 weeks. It's not exact. There's actually a fraction of a week there, but the standard is 52 weeks in a year. So now when I go to do my conversion, some of you guys, you'll make your T-chart or something like that, and you'll start filling things in. I've got to cancel off years, and I want to leave it as weeks in the bottom. So I need to put weeks in the bottom, and then years on top. And the conversion is 1 year goes to 52 weeks. So that is our conversion. We're done. Years cancel off. We have dollars on top, weeks on bottom, and now it's just a matter of multiplying out, or dividing out really, $1,742 in 52 weeks. That's our conversion. So get your calculator out. And I apologize if you hear my wife cooking dinner in the background there. She's trying to get dinner ready for tomorrow. So there's some extra noise that normally wouldn't be there. Either way, in the end, we end up getting 33.5 in the end, which means $33.5 or $33.50 per week. There we go. So here is another problem The context doesn't matter. They're just giving you stuff to make it sound like you're doing something of importance. The key is understanding how am I converting what rate to the new one. So Tyree and 3 friends attend skydiving class before their first jump. The instructor tells them they will travel at about 176 feet per second. Okay, so feet per second. The question is how many miles per hour is this? So I'm going to convert feet to miles, and I'm going to convert seconds to hours. So we have to use 2 conversions for that. Miles, 1 mile is 5,280 feet. 1 hour is 3,600 seconds. If you want to know how they get this one, 1 minute is 60 seconds, and 1 hour is 60 minutes. So they multiply these together. That gives us 3,600. So again, the book does this fraction method. I think, again, most of you probably are used to doing the box method. But notice they've got 176 feet per second, and then they're going to convert one of them to the other one. So they decided to get rid of feet first. So feet was on top, now it's on bottom, so it cancels off. 5,280 feet to 1 mile. And then second was on bottom, so seconds has to be on top. Seconds cancel, we get per hour. And then they show doing this, but really you can just get your calculator out. I'm okay with just going, okay. The numerator is going to be 176 times 1 times 3,600. Which is 63,000. 633,000, excuse me, 600. And then the denominator is just 1 times 5,280 times 1, so just 5,280. And then dividing it by that. So 120. So 176 feet per second is 120 miles per hour. Okay. So let's look at an example like that. So trains. Okay. So the TVG is a high-speed rail train in France. At its top speed, it runs at an average of 320 kilometers per hour. How many meters per second is this? Okay. So we're going from kilometers to meters, and then hours to seconds. That's our conversion. So we have to know how many meters are in a kilometer. Well, it's 1,000 meters is in 1 kilometer. And then how many seconds are in an hour? Well, we did in the last problem. 1 hour is 3,600 seconds. So we have 320 kilometers per hour. And you know, I always have an idea ahead of time how many of these I'm going to have, but if you don't know, just make 3 or 4. It's probably the most we're really going to need for right now. The next set of examples will need more. But now we can set up, okay, I want to get rid of, let's say, kilometers first. Well, kilometers is on top, so I have to put it on bottom. That means meters has to go on top. That cancels off kilometers, and now we're left with meters on top. Now I want to get rid of hours, so hours is on bottom, so it has to go on top next, and 1 hour is equal to 3,600 seconds. And now I can cancel off hours, and I have meters on top, seconds on bottom. So we'll just multiply across. 320 times 1,000. There's 320,000. I don't really need a calculator for that, but just to show you that. And then this is 1 hour times 1 kilometer times 3,600 seconds. Well, that's just 3,600. So now 320,000 divided by 3,600. Whoops. Divided by another 10. Okay. That is approximately 88.9, because it doesn't say, we'll just go to nearest 10th, meters per second. There we go. So this is the first part of this lesson where you're converting these guys where it's just from the same unit to the next one, not like from meters to miles or something like that. That'll be the next video. So, you know, if you need to, go back and run through this one again. If not, you can go on to the second video for the next set of examples.